Hello, this is Mohammed al-Maskary, and this recording is part of the assignment for a mechatronic design course for master's degree at University of Technology, Malaysia. Uh, Part of our task, we are required to design a PID controller to control tank level. So at the beginning, what we did, we actually went and took measurements of the tank. We took the dimension of the tank, and just to see how the system responds with our water pump. We recorded, we had some recorders manually. So we recorded time to reach a height at 10 mm and settling time, which is what the level that we want to control the tank at 20 mm. So when the outlet was at 100%, uh, the time to reach at 10 mm took about 1 minute and 20 seconds or so, but it couldn't reach uh, the set point that we actually required to control the level of the tank. Therefore, the outlet was way too open and the flow of the outlet is way too high than the flow of the pump. What we did after that is like we made the outlet at 50% opening. So the settling time, the time to reach at 10 mm height took about 28 seconds, and the settling time took about 53 seconds. And just to check the flow, when the outlet at 0%, like it's fully closed, um, time to reach at 10 mm height took 23 seconds. Obviously, it's very obvious. It's very, I mean, like there is no outlet, so the time to reach 10 mm is way higher or way lower than 50%. And time to reach at 20 mm is about 45 seconds. So from now on, like we're going to take this result as our standard to compare our PID controller in our tuning. So first of all, what we did is like we took our calculated, assumed calculated from assignment one traction transfer function. So we got an area, yeah, like I mean the transfer function is R over RC S plus one. We're going to assume that R is equal to on in the capacitance. It came out about 1,540 mm. So to start the tuning the controller, we what we did is like we set a proportional band at 500 and see how the controller would react with our plant, which is this one here. And as we can observe, like because we are only using a proportional band, like it will never reach our set point because the error is multiplied by the gain of the controller. But most importantly is our raise time and almost settling time is about 30 seconds. In our model, it's about 53 seconds. So the conclusion of this, like our assumed area of the tank at assignment one will never work with our model because the settling time of this model is way lower than the actual physical tank. Just to show you an example of what we did, so I just went further and tuned it with PI settings, P and I, PB at 500 and TI at 100, settling time about raise time about 9 seconds and peak time about 14 seconds and settling times about 50 seconds. Almost as our tank is like, but the raise time is way too high for our tank. Same results with more aggressive tune with a proportional band of 3000 and a TI of 100. I mean, like as we can see, the raise time is less than 2 seconds and settling time is about 40 seconds. After that, we went to measure the actual capacitance of the tank to give us the actual transfer function in the lab. This is part of the results. It's going to be included in the report. And after measuring the tank, like the capacitance of the tank, it's about 110,000 mm square. We plug this into our transfer function and we get 1 over 10,000 s plus 1. Again, um, we start tuning the controller with only proportional band just to check how the system going to react. And our results are starting getting closer to the actual physical measurements that we did at the lab. So as we can see that the raise time is way higher right now. It takes about 40 seconds. And the settling time of it will never settle. There will be a 0.5% error over there because we are only using a proportional band, but it's almost reaching um, our settling point between 70 and 80 seconds. So we can actually use this model right now to model our system and see how the system can react. After that, like we start applying a PI controller. So we took with the same proportional band of 500, and we took a TI time of 100. And as a result of this, like we can see that the system is unstable and it keeps oscillating the whole time. It might settle down uh, uh, after 100 seconds or after that, but we need to adjust the gain of this controller to start giving us a better response and uh, a more efficient system. So after that, like we raised the proportional band to 3000 and the TI, we kept it the same. As we can see, like it's over here, like um, we're getting a better response, less overshoot, and a settling time about 60 seconds, which make a lot of sense because the controller is trying to control the level of the tank as much as possible. It cannot be less than 53 seconds. It can be higher than 53 seconds if we want to make this realistic. After that, I went with more aggressive tune, with more timing, TI of 500, and a PB of 6000. The system has a very sharp raise time, maybe about 5 seconds, and it has an overshoot at about 5 seconds. But it will uh, settle the system down at the set point in about, let's say, 35 seconds. The system over here it looks good, but in reality that can't be happen because the minimum settling time that we expect from our tank will be no less than 53 seconds. So this is just as a result. Anyhow, in conclusion, as we can see in the table here, we started with a proportional band. We get a settling time at 80 seconds. With a PI controller, with inappropriate settings, like we never got the system to settle down. It kept oscillating. And with more aggressive controller and a better gain at the controller with a proportional band of 3000, we start getting a better system that can settle down maybe at 90 seconds or so. Um, but it doesn't have an overshoot, a very high sharp overshoot, and it make more sense for our system. At a very aggressive tuning with a TI of 500 and 6000, the system it has slightly overshoot, which is okay for the tank level, but it doesn't make any sense because the raise time is way too high for the actual physical tank that we have. And thank you very much. This is the conclusion of our tuning. Assalamu alaikum.